Good morning, students. This is our this is me completing the work pages of page 112 and 113. If you'd like to follow along with me, I'm going to complete it, and you can see your answers. I'm going to be doing this out loud and talking to myself. I'm also going to be using a pad of paper to work on as well, so I'll be switching back and forth. So the camera won't be perfect, but I hope that's okay with you. Because we're going to try to get through this and make sure everyone's on the same page. All right, so if you watched our last lesson, we talked about straight angles and adjacent angles and linear pairs. We talked about triangles. So let's start working on this. So the first question is match the diagram to the names. And there's a hint that the angles in a linear pair are also adjacent pairs. So we have the three listed right above here. You can see it on your book, but we're going to start matching them together. So first, we want to figure out where these fit. I'm going to go with the straight angle because I think that's the most obvious one. It's only a straight line, so I'm going to put that right here. That's going to be a straight angle. Let's see. And then I have two more. I have one right here that has a straight line and an intersection, and then I have two adjacent angles. So I'm going to put the adjacent angle over here, and my linear pair is going to go right here. Now, technically speaking, oh boy, the camera's not very focused. That's right, we'll get there. Technically speaking, this one, I believe, or sorry, this one is not just a straight angle. It could also be an adjacent angle. Oh, sorry, no, this one could be also here, but we're going to leave that for now. All right, calculate these angle sums. So we just have to add the two numbers together. So we have 10 and we have 10 and 25, so those are adding together. That's going to be 35 degrees. 30 and 40, that's going to be 70 degrees. 12 and 28, that's going to be 40 degrees. And 20 and 30 and 40, we're going to add those together, and that is 70 plus another one, so it's 90 degrees. Good. So angle 1 and 2 are a linear pair. That's what we're looking at this over here. So these two are a linear pair because they have the straight line going across. Identify the three other linear pairs in the diagram. So what we should be doing is combining any angles across from each other and adding them together. So we have 1 and 2. That's already done for us. So the next one will be 2 and 3. Those are going to be linear pairs. Then we have 3 and 4. Because we have a straight line and we have a line intersecting it. So 3, 4, and then we also have 4 and 1. Determine the sum of the angles formed by two lines that intersect at a right angle. So whenever there are two lines that are intersecting at a right angle, as we see here, 1 and 2, if we add these two angles together, this is going to be 90, and this is going to be 90, so together it's going to make 180, which is the rule of a linear pair, which we said before. So this is 90, that's together going to equal 180, which is a straight line. So angle 1 and angle 2 is 90 plus 90 equals 180 degrees. 3 and 4 is a 90, 90, that's 180 degrees. And now we have 1, 2, 3, 4, so that's 180 plus 180 all together is going to equal 360. Now the reason it's 360, I'm sorry, that's pretty messy. We have 180 plus 180, and this is the entire, we could draw a circle around this, and that is the 360 degrees. Okay, next one. Determine the sum of the angles formed by any two intersecting lines. The sum of the angles in a linear pair is always 180 degrees. Okay, that's the rule. The sum of the angles in a linear pair is always 180 degrees. This is similar to what this question is over here. So we have angle 1 and 2, because they are going to be making a linear pair. That means we got to add them together, and that's going to equal 180 degrees. 3 and 4 is the same sort of situation. It's on the other side of the line. That's 180 degrees. That means if I do 1, 2, 3, and 4 all together, they're going to equal 360 degrees. Okay, predict the sum of the four angles around any point P. Okay, so it doesn't have a point P down on here, but I'm assuming what it means is right here. That would be point P. Okay. Calculate these angle sums to check your prediction. So we actually don't need to add these all up in our head. Because they're equal 180, each little section is equal to 180. So 30 plus 120 is 180. That's the same. And I just know 180 plus 180 equals 360 degrees. And this is the same situation. These are going to combine to 180. The reason I know that they're going to add to 180 is because they are adjacent pairs. Oh, sorry, they are linear pairs. So this angle plus this angle is going to equal 180. Same with this. This angle plus this angle is going to equal 180. Okay, so I don't have to do all the extra math in my head. I can just write down the answer. Okay, so that's that first page. Let's move on to the next page. Change my camera a little bit. All right, next one. So determine the measurement of angle x or xzy. The sum of the angles in a triangle is always equal to 180 degrees. We know that as a rule. So we're going to now figure out what the angle z is, because we actually know what x is. X equals 90 degrees, and y is 60 degrees, so we got to figure out what z is. So it's sort of showing us how we can do that by process of elimination. So because we know these two angles already, which is these guys, we want to take 180 and we want to take away 60 and 90. That's what the goal is. So I'm going to put 180 up here. And we're just going to do step by step, so essentially process of elimination. So 180, subtract these two numbers. These two numbers combined is 150. 180, subtract 150 equals 30. So that tells us actually that this angle right here is 30 degrees. Actually, I should be putting that actually inside, not there. Okay. So we just did a little bit of mental math. We knew that this was 90 because of the square. And it told us what 60 is, so that means the only thing left over is going to be 30. Okay, now with that same idea, we're going to keep going. So we have angle A equals 180, subtract 80 plus 30. Now the reason we're doing that is because we know an entire triangle is 180 degrees, and we're trying to find only angle A, and we might as well take away these two things from 180 degrees, and then that's going to tell us what angle A is, because that's all left over. So we have 180 subtract 110, which equals 70 degrees. Okay, so this right here, 70 degrees. Next one. Now they're taking some information away from us, and we have to do a little bit more work. We know that every triangle is 180 degrees. They've given us two of the measurements, which is 30 and 30. Add those together, we have 60, and 180 subtract 60 is 120. That means this right here is 120 degrees. Okay, and our next one, they give us 40, and it doesn't look like they give us this, except if we recognize this square shape right here, that tells me that this angle right here is 90 degrees. So that means I have 90 and I have 40, and I'm taking away 180 from those two, or 180 take away those two. So 90 plus 40 is 130. I have to take 180 subtract 130, and that gives me 50 left over, and that means this angle right here is 50. Okay, so this is all working on the idea that triangles are made up of 180 degrees, and if we know two angles, then we should be able to figure out the third one, because there's only so many left. Determine the measure of angle F and DEF without doing any calculations. So, I don't know why this is here, to be honest. Oh, okay, it's just the exact same. My bad. Alright, so these are two of the exact same triangles. They're congruent to each other, and they just take away, and they're like, ooh, what's the last one over? So, we could just look over here and say, okay, well, 20, just by looking at it. We could also do mental math in our head. We could say, well, we have 180, we're going to take away 130, take away 30. So 180 take away 30 is, 180 take away 130 is 50. Take away another 30, we have 20 left over. Or we could just look at this triangle and say, well, obviously, these two guys are the same. So 20. All right. Now we're going to start working in on my book here. I'm going to read the question, but I'm not going to flip back and forth. So you just got to pay attention to me. This is number 10. And it says, this is number, all right, so page 113. We're doing the numbers 10 through 13. And this is number 10. All right, this is number 10. The question says, a triangle has a 30-degree angle and a 60-degree angle. What is the third angle in the triangle? So I want to find out what the third one is. And I'm going to do, let's make it X just to make it easy for myself. So let's say angle X equals 180 degrees. Take away these other two angles. 30 plus 60. 180 equals 180 degrees. Subtract 90, and my angle is 90 degrees. Okay, so I'm trying to replicate what they did in the book. It should look pretty similar to this. That's why I'm doing it that way. If you do it somewhere different, that's fine. You could do 180, take away 30, take away 60. Whatever, as long as you're getting the final answer. That's kind of what the important part is. Okay, the next one, we have question B. I'm trying to make sure I'm leaving space as well, so I'm leaving a space here. B, a triangle has two 45-degree angles. What is the third angle? So we have angle X again, and let's give myself a little bit more space. Angle X equals 180 degrees, take away 45 degrees plus 45 degrees. And that means 180 take away 90. There we have it. Okay, we got 90. Next question, C. I'm also trying to line up, so I'm leaving a space right here. There's a square separate. I'm also trying to line up my A's and B's to make it uniform. A triangle has all angles equal. What is the measure of each angle? Okay, so this one's a little bit different. So we have 180. Now we can't really do a subtract. We could somehow, but what works in my brain right now is I'm thinking 180 divided by 3. And that's going to give me the answer 60 degrees. Because it says all the angles are equal. There are 3 angles in every triangle, so 180 is what every triangle makes up. Divided by 3 equals 60. And there we have our answer. All right, number 11. I'm going to move down a little bit and make sure I leave equal space. 11A. Could a triangle ever have more than one obtuse angle? So, could a triangle ever have more than one obtuse angle? So if I draw an obtuse angle for a moment, and then I'm going to try to combine it. I don't know if you can see this very well. Sorry. That's a really ugly obtuse angle. That's obtuse. Now the thing about obtuse angles is every obtuse angle is always more than, I have to think about how to do this, more than 90 degrees. It's always more than 90 degrees. So that means every triangle only has 180 degrees, and if an obtuse angle is more than 90 degrees, I will never be able to, I will never find a triangle with 2 obtuse angles. It just doesn't work because an obtuse angle is more than 90 degrees, and every triangle has 3 angles. So if I have one angle that's more than 90 degrees, there's not enough for me to have another 2 angles. It won't ever work. Okay. Now let's look at question B. Could a triangle ever have more than one right angle? So this is the same sort of situation. I have a right angle here. Okay, so that's one right angle. Let's see if I can do 2. No, because it doesn't combine. By definition, a triangle always has to have 3 angles. So then I will never find a triangle that has 2 right angles. It's not possible. Good. Now we are on to number 12. Number 12. We're still working on page 113. Number 12. Let's see what you got here. A triangle. Sorry, measure and mark the angles on each square. Okay, so I'm not going to. Actually, I can show you what it looks like. This angle right here, I can measure them. So this is obviously 90s. Those are 90s. And I can measure these guys. I'm going to measure the bottom one because it's easier for me, personally. But you can measure either one. This is a 45-degree angle. You can see it's lining up right in between the 40 and 50. So that's a 45. And if I know one angle, then I should be able to figure out the other angle. It's also 45. I've measured this one before. It's going to come out to 30 and 60. 30 is going to be at the bottom. I'm going to make sure I'm lining up really nicely. You can see right here. Actually kind of nicer than doing it at school. It's a little bit, it's got some marks on it, but that's okay. Alright, so what we're looking at and seeing is we're going to line up this bottom guy along the 0. My vertex is right there, and you're going to see it follow along this line exactly, which is the 30. If you're not sure if it's 30 or 50, just look at the angle again and say to yourself, okay, like an acute angle is less than 90 degrees. Obviously, 30 is less than 90 degrees. So that means this is 30, and that is 60. Okay, now use a set square to draw two lines that intersect at 30-degree angle, 45-degree angle, and 60-degree angle. I'm going to draw that right here. So let's do one line. Oh, that's a really not a good line. Let's try again. There's a line. This is A. Oh, come on, fingers. B. C. And we want to have a 30-degree angle. It's a 30-degree angle. This one is a 45-degree angle. Okay, so that's actually right through there. And the last one is a 60-degree angle. I drew these in a really poor spot now that I'm looking at my work, unfortunately. So I'm doing a little bit of... There's a little bit of guesstimation. It's not perfect. I probably could do it neater. Okay, so this is 30, 45, and 60. Put little degree signs. Okay, and number 13. A triangle has two equal angles. One of the angles in this triangle measures 20 degrees. What are the other angles? There are two solutions. So, all right, so we have 180. Take away 20. It's not angle X exactly. Okay, so what we have right now is we have two angles, and we have two options. Okay, so what the question is saying is there's one angle that's 20 degrees, and we need to figure out what the other angles are. Now, there are actually two options. We could have two angles. Oh, sorry, the triangle has two equal angles. So the one option is we have two 20-degree angles. And that means that my leftover would be 180 take away 40. And that means I have 140. I'm sorry, I'm doing this kind of messy. And then the other option is, so that means that there's two of them. The other option is I have one 20-degree angle and I have two of the same, the other ones. So I have 180 take away 20, which is 160. And I'm going to divide that by 2, which gives me 80. And so I have two 80-degree angles. Okay, so my options are I have one triangle that has a 20-degree, a 20-degree, and 140-degree. That's triangle 1. Or I have triangle 2, which has a 20-degree and an 80 degree, and an 80 degree. That's my other option. Because the question said I have two angles that are the same, that's the same, and that's the same, those are my two options. Okay, for question B, this was a little bit different. I have two equal angles. One of the angles in the triangle measures 100 degrees. That means, because we said before you can't have two obtuse angles in a triangle, I'm going to do 180, take away 100. That means I have 80 left over, and I have to have my two other angles come out of that. So 180 divided by 2, so that means I have 40 degrees. So this triangle is 100 degrees, 40 degrees, and 40 degrees. And my last question is how are problems A and B different from each other? Why do they have different number of solutions? Well, because you may only have one obtuse angle in a triangle by definition. Whew. Right, so we got through page 112 and 113. I hope I didn't go too quickly. If I did, you can always go back in the video and pause and see how I did it. And if you have any questions, please send me a message on Teams. I hope this was helpful, and have a wonderful day.